This video provides for a summary of the great book on asteroid detection mitigation, written by an extraordinary space professional, Mr. Dutch von Ehrenfried, a NASA physicist and flight controller. He was part of the team that built the NASA space program, there at the infancy for the Mercury and then later Gemini and Apollo programs. Now retired, he continues to crank out timely books on the space program. I highly recommend his books, which are available on Amazon.com. I now introduce Mr. von Ehrenfried.
Hello, I'm Dutch von Ehrenfried, former NASA flight controller for programs Mercury, Gemini, and Apollo. I'm the author of one of a dozen books, including Asteroid Detection and Mitigation in the 21st Century, the subject of this video. In researching information for these books, I contacted many prominent scientists for their experiences and opinions. And he wrote the forwards to these books, including Nobel Prize winners and principal investigators. For this book, Dr. Sean Gulick of Chicxulub fame from the University of Texas at Austin provided his expertise. I found that the public is very misinformed about asteroids and comets and the threat they potentially pose to Earth. They are also generally unaware of the worldwide efforts to better understand the threat that these asteroids and comets may or may not pose to Earth, meaning you're not aware of the efforts to mitigate the potential consequences of impacts on Earth. Popular culture often depicts asteroids as chaotic objects that zoom haphazardly around our solar system, changing course unpredictably and threatening our planet without a moment's notice. This is not reality. As you can see from the image below, many asteroid locations and orbital paths are known and are quite predictable. Asteroids and comets are extremely predictable celestial bodies that obey the laws of physics and follow knowable orbital paths around the sun. But sometimes these paths come very close to Earth's future position, and because of small uncertainties in the asteroid's positions, a future Earth impact cannot be completely ruled out. So astronomers use sophisticated impact monitoring software to automatically calculate the impact risk. A near-Earth object, called an NEO, is an asteroid or comet whose orbit brings it within a zone of approximately 121 million miles from the Sun, meaning that it can pass within 30 million miles of the Earth's orbit. The one most people are familiar with is the Chelyabinsk meteor that made the news in 2013. As you can see from the image below, the Chelyabinsk asteroid came within the orbit of the Earth and exploded over the city. Today, there are approximately 30,000 near-Earth objects and over 100 known short-period near-Earth comets being tracked, of which less than 1,500 are on the JPL risk table. Only about 20 of those objects are considered large enough to qualify as potentially hazardous objects, those with a diameter greater than 500 feet. That means that 99% are less than that size. Scientists are tracking much smaller objects. They estimate that the minimum asteroid size to cause of fatalities is 56 meters or 184 feet. The following is an image of a large fragment of Chelyabinsk asteroid found in the lake 50 miles west of the city. On January 26, 2023, asteroid 2023b made what NASA called a very close encounter within South America. It was only 2,200 miles above the Earth, well within the orbit of the geosynchronous satellites. It was about 11.5 by 28 feet. And even if it did impact Earth, it would have turned into a fireball and largely disintegrated. The following shows the asteroid in red coming inside the Earth's orbit in green and passing over South America and then back out again. The following image shows the ESA kinetic impactor Hidalgo impact on the moonlet Dimorphos in order to change the orbit of Didymos. The Lycaea cube Sancho records the impact to eject a cloud in impact crater. This experiment was a great success on many levels. The effects are still being analyzed, but they definitely demonstrate that we have a way to deflect an asteroid. We now must learn how to use this capability. No one should be overly concerned about an Earth impact of an asteroid or comet, even though the typical comet is about 10 kilometers or 6.2 miles in size. They come from a much farther out and are tracked for long periods. The threat to any one person from auto accidents, disease, other natural disasters, and a variety of other problems is much higher than the threat from NCOs. Over long periods of time, however, the chances of the Earth being impacted are not negligible, so that some form of NEO insurance is warranted. At the moment, our best insurance rests with the NEO scientists' efforts to first find these objects and then track their motions into the future. We need to first find them and then keep an eye on them. Fortunately, NASA, JPL, and its international partners have identified more than 95% of all asteroids that are large enough to cause a global catastrophe, and none of those found pose a threat within the next 100 years. So, sleep tight.